Once again, I welcome all of you in today's lecture. In the last lecture, we were seeing that the important things regarding about the non-uniform flow in open channel, okay? And we also seen that the different problems means we have to calculate the specific energy, then critical depth in the channel, critical velocity and E minimum. So in the today's lecture, we are going to study the another articles, that is notches and weirs. So I am going to share with all of you the today's presentation. So these are the things we were seen in the last lecture. Okay, we have a problem. Okay, a rectangular channel has a bed slope of width 5 meter and depth of flow is 1.3 meter. The discharge is 20 meter cube per second. Calculate specific energy, critical velocity and E minimum. Okay, that is the specific energy minimum. So we were calculated the values and we were obtained the answer, that is E minimum, that is the total energy 1.782 meter, then critical depth 1.17 meter. Okay, then also critical velocity 3.39 meter per second, and E minimum, that is the specific energy minimum 1.75 meter. So these are the things we were seen in the last lecture. Now in the today's lecture, if you see the syllabus, what we have covered up till now, my slide is visible?
Yes, sir.
Yes, sir.
Okay. Okay. So from the first module, that is the uniform flow in the open channel, we of types of flow in open channel, geometric element, velocity distribution, measurement of velocity with the help of pitot tube and the current meter, then weir and spillway, then measurement broad crested weir, okay, round crested weir, then the another thing is that the calibration of weir, time of emptying tank with the weir, profile of Ogi spillway, flow below gates. So from the module 1 we have covered up to the velocity measurement with the help of pitot tube and current meter. The remaining portion is from weirs and spillway. Okay. And from module 2 we have covered the Chase's and Manning's formula, okay, for designing of the channel. Then we also covered uniform flow. Then we also seen that the most economical rectangular, triangular, trapezoidal and circular section, and we also solved the problems. Then in the last two lecture we have covered this specific energy, okay, definition and diagram, then concept of critical, subcritical and supercritical flow. Then also we have seen that how to calculate the critical velocity, critical depth, E minimum, total energy with the help of numerical problems. So almost all in the module 2 we have covered. Now after having the knowledge from the module 2, we are going to learn notches and weirs uh, from this onward this syllabus, okay, from the module 1. So basically, what do you mean by the notch and what do you mean by the weir? Okay, so I am going to tell you the definitions of the notches and weirs. For example, if you want to measure the discharge, okay, for example, we have the channel, any type or any shape. In this diagram you can see this is a trapezoidal channel. Now if you want to measure the actual discharge, okay, for example, if you want to supply the water for the crops in case of the field, so we have the field here, okay, and the channel is started from the base of the dam, okay. So I am going to describe with the, okay, about the notches and weirs, okay. So first is notch and weir. So what is notch and what is weir? How to measure the discharge with the help of notch and weir? I will describe you. For example, we have a dam, okay. So basically this is the cross section of the gravity dam, okay. This is the cross section of a gravity dam. Then the another section is like this, okay. This is the another section. Now we have the highest flood level here in the dam itself. This is a dam and the water is stored up to this particular height from the bed of the dam. So this is the total depth of water on the upstream side of the dam. This is upstream side, okay, and this is downstream side of the dam. Then we have the channel, okay, or canal. For example, in the longitudinal section, for example, the river is flowing in this direction, okay, this is the river and the water is flowing in this particular direction. So we have to construct a dam across the river for the purpose of storage of the water. So this is a barrier we have constructed across this particular river. So on the upstream side we have to store the water. So this is the water, okay, on the upstream side of dam. Now with the help of canal or channel we have to supply the water for irrigation. So we have two types of the channel, that is left bank canal and right bank canal. So the channel is started from the both the side of the dam. For example, here we have the right bank canal, okay. So RBC, right bank canal, and we have another canal. So this is left bank canal, okay. So in case of the Jaikwadi dam, we have two channel, left bank canal and right bank canal, okay. Now the channel is started from the base of the dam. So this is the base, okay, or one side of the dam, and on both the side of this canal, this is the main canal, okay, this is main canal. And with the help of this main canal, or this is also a main canal, both are the main canal, okay, and it will cover both the catchment or both the area on both sides of the dam. For example, this is the main canal, then on the main canal there is another canal, we called it as a major distributary, okay, major distributary. This is major distributary, this one. Now this canal will carry forward for supplying water to the another area. Then we have to connect a major distributary to the main canal, then the main canal to the major distributary, another minor distributary we have to connect like this. This will go for another area. Now here we have another the connections at this section or at this junction, that is minor distributary. Minor distributary. Okay, and from this minor distributary we have to supply the water. Okay, minor distributary goes for another area. Then this is another section we have to connect another small channel, that is known as water course. This is water course. Okay, and at the end of this water course we have the field. Okay, at the end of this we have the field. This is our field, that is the this is our field. Here we have to take the crop. These are the different types of the crop. Okay, this is field. So how to distribute the water from a dam? This is a particular dam. Okay, so how to distribute the water up to the field? First we have to supply the water from the main canal. Then from the main canal we have to divert this water in the major distributary. Okay, and then we have to distribute this water in the minor canal. Okay, and then from the minor canal we have to supply the water for irrigation in the field. So how to distribute the water from dam to the main canal, major distributary, minor distributary, and at the end of this minor distributary we have the water course and then field. This is the distribution pattern of the water from the dam to the your field. Now, as a hydraulic engineer, our responsibility is that we have to measure the discharge at each and every section. Okay, for example, if you want to supply the water for the irrigation purpose, for example, 10 mld or 2 cusecs or 50,000, okay, 50,000 liter per hour or per second. For example, this is the a discharge we have to supply in the main canal. Now the length of the main canal, for example, 324 kilometer or something length will be there, 300 kilometer or 200 kilometer length of the main canal. Now we have released the water how much? 50,000 liter per hour. Now we have to measure this at a particular interval. For example, at this section, this is the first section we have taken from the dam up to a 10 kilometer. Then another section we have to take from the first section. The distance between these two sections is 10 kilometer, and then further. So we have to check whether the release discharge is coming at this particular considered you can say the section or at this section. म्हणजे आपल्याला चेक करायचं असतं, we have to check whether the release discharge is coming at the section 1 or 2, or some losses will be there due to the evaporation or due to the leakage or due to the percolation through the bed of the channel. So we have to check it whether we have got correct discharge at any section at any particular location, so as to we can deliver the discharge with required pressure, velocity, and required discharge at a particular field. So we have to again measure Q here also, how much Q we will get at this point. So we have the notches and weir. For measuring the discharge in the canal, we have the notch and weir. Okay. So how will you measure the discharge with the help of notch and weir? This is the one of the important arrangement which is made across the channel. Okay. So what is notch and what is weir? Basically, notch is a arrangement which is made across the channel for measuring the discharge. Okay. So see here, the notch is what is notch first? Okay. First, I would like to discuss with you the definition of notch. Okay. A notch may be defined as an opening provided in one side of a tank or the channel or reservoir with upstream liquid level below the top edge of the opening. Okay. So if you want to measure the discharge in the channel, okay, if you want to measure this discharge at any location in the channel, so with the help of notch we can measure it. How we can measure it? So notch is the arrangement made across the channel for measuring the discharge. Okay, discharge we have to measure with the help of notch. It is made up of it is made up of with metal. Okay, notch is constructed with the help of metal, that is iron or steel, any types of the metal we have to use to notch. For example, we have a rectangular, this is the rectangular channel, the depth of the channel D or H in meter, and we have the width of the channel. Okay, this is the width of the channel in meter. And if you want to measure this Q, that is the discharge in the channel, so we can measure with the help of notch and weir. So exactly the shape of the notch and weir we have to manufacture as per the shape of the channel. For example, the shape of the channel is rectangular, so we have to manufacture the shape of the notch or weir as a same as per as concerned with the channel shape. So I am going to attach here notch. So see here, this is the notch. Okay, this is the notch. We have to place this notch across the flow, okay, at an angle 90 degree. So this is a particular notch, this is the notch. Okay, this is a rectangular notch. Okay, and this portion is solid portion. Now this portion is solid portion. Now this level is known as the seal level. Okay, this is seal level or crest level. Okay, then the water is coming from the channel or from the dam in the channel, and then it is flowing through the body of the notch. Okay, so this is a notch and the water is flowing above the seal level or the crest level in the notch like this. Okay, this is the water is flowing in the notch. Now what we have to do, we have to record this rise of water level above the notch or sill level. Okay, so we have to record for different opening of the gate from the dam itself. Sometime we have to supply more discharge, so we have to open maximum amount of flow which is flowing through the channel. Then ultimately the rise of water level above the sea level in the notch will be more. And then again what we have to do, again if the discharge will require more, then we have to open more gate from the dam, and then again we require this H. Okay, so as far as concerned with your demand, okay, we have to open the gate and we have to measure the this H. Now this is about the notch. Okay, so we have the rectangular notch and rectangular weir. Okay, we have the trapezoidal notch, trapezoidal weir. As the shape of the channel, we have to place the same shape for the notch and weir. Okay, for example, if we have the trapezoidal channel, so we have to place the trapezoidal notch or weir across the flow. If the triangular channel will be there, then we have to place triangular notch or weir across the flow in the channel for measuring the discharge. Okay, now this is a trapezoidal notch or weir. Okay, now this is, in this diagram you can see here, this is a trapezoidal weir. Okay, so notch is made up of with the help of metal, any types of the metal, iron, steel or aluminum, any types of the material we have to use for manufacturing purpose. But what do you mean by weir? So weir is a concrete structure which is constructed across the flow in the open channel for measuring the discharge. So if you see here, we have the sill. Okay, this is the trapezoidal weir. So this is the sill level. Okay, this is sill level. Sill level. Okay, this is sill level for the notch or weir. For example, this is a channel. Okay, so we have to construct such kind of the shape like this. Okay, this is the shape for the trapezoidal shape for this particular weir. Okay, this is weir. Weir is a concrete structure which is constructed across the flow. Now this is the flow. Okay, that is, this is discharge coming from the dam, and if you want to measure how much discharge which is coming from the dam, then we have to construct such kind of structure across the flow. This is made up of with the help of concrete. Okay, so this is a concrete weir we have constructed across the flow for measuring the discharge. Now this is the sill level. Okay, now above this sill level, now this is your rise of water level, that is H. Okay, so what is this H? H is the rise of water level. So for different discharge, for different dam gate opening, we have to record this H, and we have the formula for any kinds of the notch and weir. Once we have measured this H, then we will get the discharge. Okay, so how to measure this discharge with the help of notch and weir, that is the things I would like to discuss in the today's lecture. But before that, remember, if the shape of the channel is rectangular, trapezoidal, triangular or circular, so we have to provide any kinds of the notch and weir across the flow for measuring the discharge in the channel. So remember that. How will you define notch and weir? Notch and weir is a structure which is constructed across the flow in the open channel for measuring the discharge. That is known as notch or weir. Now, if you see here, we have different types of the notch and weir. We have the rectangular notch, triangular notch, trapezoidal notch, and step notch. Okay. So, I am going to discuss with all of you the discharge over a rectangular notch or weir. Okay. So, for example, we have the here we have the a rectangular channel here. Okay, this is a rectangular channel. Then we have to place a same shape as the shape of rectangular. We have to place a rectangular notch. So this is a rectangular notch we have placed across the flow in the open channel for measuring the discharge. Now we have the crest level or the seal level. Okay, so this is the seal level. Then this is the length of the weir or notch. Then this is the total depth of flow. Okay, and then for the from the total depth we have to consider a one layer of the fluid which is having the thickness dh. So dh is the thickness of one thin water strip. Okay, so I would like to discuss these things with the okay. So the next things I would like discharge through a hello, my voice is audible? Hello, my voice is audible?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Now discharge through a
Hello, sir.
rectangular notch
Hello, sir.
or okay. Yes,
Hello.
yes.
Sir, screen has been stopped, sir. Means it is making glitches. It is stopping, then starting.
Now
No, sir, it is to stop at one.
आता दिसते का?
नाही सर, स्क्रीन पॉज झाली असं वाटतं सर. म्हणजे काही तुमचा हात फक्त दिसला आणि पाय मुवमेंट नाही होते.
आता दिसतं? Yes. Anybody tell me? Can you see the droid cam? Yes.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So discharge through a rectangular notch or weir. म्हणजे आपल्याला इथं रेक्टँग्युलर नॉचनी डिस्चार्ज काढायचा आहे फ्रॉम दी चॅनल. So we have a derivation discharge through a rectangular notch or weir. Okay, so consider a rectangular notch. Okay, so I am going to first draw the section. Okay, so this is the rectangular notch. Okay, or weir, this is the crest level or seal level. Okay, for example, we have constructed such kind of notch or weir. Then the water is coming from this side, from the dam. Okay, आणि एका लोकेशनला आपण असं एक नॉच बसवलेली आहे. वाटर कमिंग ओके लाईक दिस फ्रॉम द dam, and then from this crest level, this is crest level or sill level, okay. From this crest level or sill level, what will be happening? The water is flowing above the sea level like this, ओके. जिथं आपण हे बसवलेलं आहे चॅनल मध्ये, त्या नॉच अँड वियर वरून असं पाणी खाली आहे, म्हणजे इथून पण चॅनल आहे, ओके. फ्रॉम दिस ऑल्सो द चॅनल इज कंटिन्यू, बट ॲट ए लोकेशन इथं आपण असं नॉच और वियर असं बसवलेलं आहे. सो दिस इज द केस ऑफ द flow over the notch or weir. Now above the sea level we have to record this H, okay. This is H, that is the head above the sea level. What is this H? H is the head above sea level or crest level, okay. Sea level or crest level. Can anybody tell me, can you see all these things clearly? Yes.
Yes, sir.
Okay. So what is this H? H is the head above the sea level. म्हणजे आपण काय केलं, चॅनल मध्ये एक नॉच, रेक्टँग्युलर नॉच बसवली आणि डॅम मधून पाणी आपण डिस्चार्ज केलं, ओके. दिस इज क्यू. आता एका पर्टिक्युलर लोकेशनला आपण हे बसवलेलं आहे नॉच, आणि त्याच्यावरून मग काय होईल, पाणी जाईल आणि परत इथून त्याच्या डाऊनस्ट्रीम्सला चॅनल असतात, तिथून परत पाणी तिकडे जाईल. So this is the flow over the notch or weir, okay. Now what we have to do, आता इथं पूर्ण अशी हाईट आहे, तर इथून आपण काय करू, समजा इथं असा आपला चॅनल आहे, नॉच आहे, ओके, आणि ही पूर्ण डेप्थ आहे पाण्याची त्याच्यावरती, सील लेवल. दिस इज द सील लेवल, ओके, और क्रिस्ट लेवल. ही पूर्ण डेप्थ आहे आणि ही नॉच और वियरची लेंथ आहे, ओके. तर आपण अगोदर एक स्ट्रीप कन्सिडर करून त्याच्यामधलं आपण डिस्चार्ज काढू. सो वी हॅव टू कन्सिडर वन सिंगल स्ट्रीप, म्हणजे आपण एक सिंगल स्ट्रीप कन्सिडर केली. पूर्ण हाईट आपण आता कन्सिडर करणार नाही. पहिल्या सिंगल स्ट्रीप मधून आपण डिस्चार्ज काढू, नंतर पूर्ण हाईटला आपण इंटिग्रेशन करून डिस्चार्ज काढू शकतो. सो वी हॅव टू कन्सिडर ए सिंगल स्ट्रीप which is having the thickness dh, okay. आणि ही फ्री वॉटर सरफेस पासून आहे at a distance h, okay. So what is this h, small h? H is the of strip, height of strip from free water surface, okay. फ्री वॉटर सरफेस म्हणजे हा फ्री वॉटर सरफेस आहे, दिस इज फ्री वॉटर सरफेस. तिथून आपण एक स्ट्रीप कन्सिडर केली, ही कन्सिडर स्ट्रीप आहे, ओके. कशामुळे आपण ही स्ट्रीप कन्सिडर केली, अगोदर आपण एका स्ट्रीप मधून जर डिस्चार्ज काढला तर पूर्ण हाईटला आपल्याला इंटिग्रेशन करून डिस्चार्ज काढणं सोपं होईल, त्याच्यासाठी आपण एक सिंगल स्ट्रीप कन्सिडर केली. सो दिस इज dh. dh इज द थिकनेस ऑफ सिंगल स्ट्रीप. सो व्हॉट इज दिस dh? थिकनेस ऑफ सिंगल स्ट्रीप, थिकनेस ऑफ सिंगल स्ट्रीप, ओके. थिकनेस ऑफ सिंगल स्ट्रीप. आणि L, लेंथ ऑफ notch, okay, length of notch. So these are the abbreviation we have used. कॅपिटल एच इज द हेड ऑफ द सी लेवल, म्हणजे टोटल हेड आहे हा जो आपण इथं दाखवलेला आहे क्रॉस सेक्शन मध्ये. आणि पूर्ण डेप्थ आपण कन्सिडर नाही केली above the sea level. We have to assume a single strip. Once we have the discharge through the single strip, then it is very easy by integration. We can calculate the discharge for this whole depth of the flow or the head above the sea level. And h is the height or the distance from the free water surface. Okay. So these are the notation abbreviation. Now the area of strip, we have to calculate first area of strip. Okay, आपल्याला area of strip काढायचा आहे. So how will you calculate it? Area of strip L into DH. Okay, for example, this is the strip, a rectangular strip. Okay, so how will you calculate the area of this strip? The length of the strip into dh, b into d. So b is the L, d is the dh. Okay, so the length of the strip is L into dh. Okay, then the theoretical velocity of water flowing through the strip. So theoretical velocity v theoretical. So as far as concerned with the current meter, under root 2gh, हे आम्ही काढलेलं आहे करंट मीटरने theoretical velocity. Okay, we have seen in the last lecture also how will you calculate the theoretical velocity. So with the help of current meter. Okay, हे कशाने आली? करंट मीटरनी आपण theoretical velocity काढलेली आहे, current meter. Okay, now once we have the theoretical velocity under root 2gh, then we have to calculate the discharge through the single strip. Okay, so the discharge through single strip, okay, that is dq. म्हणजे ही जी सिंगल स्ट्रीप आपण कन्सिडर केलेली आहे याच्यामधून अगोदर आपण डिस्चार्ज काढू. वन्स वी हॅव द डिस्चार्ज थ्रू सिंगल स्ट्रीप, देन वी कॅन कॅल्क्युलेट द डिस्चार्ज फॉर द होल डेप्थ ऑफ द flow above the notch seal level. So dq, how will you calculate dq? That is discharge cd into area into velocity. Okay, area into velocity. So cd is the coefficient of discharge, area into velocity. Okay, area of strip single strip into theoretical velocity. So CD into area, we have calculated earlier area of the single strip, L into DH into V theoretical root 2GH. Okay, root 2GH. Remember that where is CD, what is CD? Coefficient of discharge. Okay, coefficient of discharge. CD काय असतं? Coefficient of discharge. Then this is the dq, that is the discharge through the single strip. Now we have to measure the discharge through whole depth of the flow. So now discharge for total head. Okay, total head, that is h above seal level. आता आपण एक सिंगल स्ट्रीप मधून हा डिस्चार्ज काढला. आता पूर्ण डिस्चार्ज काढू या हेड साठी. सो दिस इज द टोटल डेप्थ ऑफ फ्लो और हेड अबव द सी लेवल. ओके, सो फॉर दैट पर्पस what we have to do, discharge q is equal to, so this is the discharge, total discharge. Okay, total discharge. This is the single discharge, okay, through the single stream. So integration of 0 to h. What is this 0 to h? Remember, integration of 0 to h. जेव्हा आपण कमी पाणी डॅम मधून सोडतो तर हा h व्हॅरीज होतो. सो दिस इज व्हॅरीज विथ द ओपनिंग ऑफ द गेट. डॅम मधून जर आपण कमी गेट ओपन केले तर इथं जो हेड आहे, टोटल डेप्थ अबोव द सी लेवल, कमी भेटणार आहे. जास्त डोअर ओपन केले तर हा जास्त होईल. सो इट इज डिपेंडेंट ऑन द डिस्चार्ज कमिंग फ्रॉम द डॅम. ओके. सो अगोदर इथं 0 लेवल असते पाण्याची, ओके, अबोव द सी लेवल, आणि तो कुठपर्यंत जातो, h हाईट पर्यंत. दॅट्स वाय फॉर कॅल्क्युलेटिंग द टोटल डिस्चार्ज वी हॅव टू टेक इंटिग्रेशन 0 टू h. हा समजलं सगळ्यांना कसं घेतलं इंटिग्रेशन 0 टू h? एनीबडी कॅन टेल मी? यस, यस, एनीवन? यस, ऋषिकेश, ऋषिकेश,
Yes, sir. Yes, sir.
understood how we will take this integration 0 to h? समजलं? अविनाश, ऋषिकेश,
Yes, sir.
हे समजलं कसं घेतलं 0 टू h?
हो सर.
तेजस्वनी ताठे, तेजस्वनी, तेजस्वनी इज देअर? तेजस्विनी, तेजस्विनी ताठे?
Yes, sir.
Can you understood this? How you will take this integration 0 to h? समजले तुम्हाला? तेजस्विनी, हाँ?
Yes, sir. Yes, sir.
Can you see this slide? तुम्हाला दिसतं काय बरोबर? चांगलं दिसतं? डेरिवेशन? तेजस्विनी, तेजस्विनी काठे, यस, निलेश, निलेश तुम्हाला दिसतं काय?
दिसते
चांगलं?
सर. हा.
दिसतं ना?
यस. हा.
ओके. सो हे समजलं तुम्हाला 0 टू h कसं घेतलं? यस, 0 टू h? एनीबडी कॅन टेल मी? समजताय काय 0 टू h कसं घेतलं इंटिग्रेशन टोटल डिस्चार्ज साठी?
नाही सर.
हा, यस.
नाही कळालं सर.
हे बघा इथं जे आहे, आपण काय केलं, आपल्याला डिस्चार्ज काढायचा आहे नॉच अँड वियरने. आपण अशी नॉच और वियर चॅनल मध्ये बसवलेली आहे, बरोबर? चॅनल मध्ये बसवली आहे. त्याच्यानंतर आपण काय केलं, ही जी टोटल डेप्थ आहे याला सील लेवल म्हणतो आपण, ओके, नॉच अँड वियरची. त्याच्यावरती ही टोटल डेप्थ ऑफ फ्लो आहे. इथून आपण काय केलं, डॅम मधून पाणी सोडलं. पाणी सोडल्याच्या नंतर जिथं आपण नॉच और वियर बसवलेले आहे तिथपर्यंत पाणी येईल, आणि मग काय होईल, ही त्याची जी सी लेवल आहे त्याच्यावरून असं पाणी खाली जाईल, ओके. आणि इथं हा ही जे टोटल डेप्थ आहे, ही डेप्थ ऑफ फ्लो आहे अबोव द सी लेवल. ओके, दिस इज द डेप्थ ऑफ फ्लो. आता इथून जेव्हा पाणी सी लेवल वरून जाईल, इथं 0 लेवल आहे अगोदर. ओके, जसं जसं पाणी इथून वाढणार आहे तसं तसं ही हाईट पण वाढणार आहे सी लेवल वरती. ओके, आणि मग 0 टू एच म्हणजे सुरुवातीला पाण्याची लेवल 0 आहे अबोव द क्रिस्ट लेवल. जसं जसं इथून पाणी वाढेल तशी तशी ही डेप्थ वाढेल, आणि इथून जर पाणी कॉन्स्टंट झाला तर ही एच पण काय होईल, टोटल डेप्थ ऑफ फ्लो अबोव द सी लेवल, ती पण कॉन्स्टंट होऊन जाईल. ओके, तर 0 टू एच, तर आपल्याला पूर्ण हा डिस्चार्ज काढायचा आहे. ओके, दिस क्यू किती डिस्चार्ज चॅनल मधून फ्लो होतो आणि कशामुळे आपण काढतो ते आपल्याला शेतकऱ्यांना मोजून पाणी द्यायचं आहे त्याच्यामुळे. ओके, वी हॅव टू मेजर द डिस्चार्ज अँड अकॉर्डिंग टू द रिक्वायरमेंट ऑफ द फार्मर वी हॅव टू सप्लाय द डिस्चार्ज. त्याच्यासाठी ही एक नॉच अँड वियर आपण चॅनल मध्ये बसवतो आणि अशा प्रकारचे तिथं फ्लोचा डायग्राम बनतो. ओके, तर इथं 0 लेवल आहे पाण्याची. जसं जसं पाणी इथून येईल तसं तसं त्याची लेवल सी लेवल वरून वाढेल. ओके, तर 0 टू एच. सो दिस इज इंटिग्रेशन 0 टू एच, म्हणजे सी लेवल वरून जेव्हा पाणी वाढेल तो एच पर्यंत वाढेल. ओके, सो दिस इज द इंटिग्रेशन साइन यू हॅव यूज. देन CDL √2G H. ओके, √2G H TH, जे सिंगल स्ट्रीप मधून आपण डिस्चार्ज काढलेला आहे तसंच आपण आता पूर्ण हेड साठी डिस्चार्ज काढणार आहे. सो दॅट्स वाय आय हॅव टेकन दी इंटिग्रेशन साइन. ओके, देन वी हॅव टू टेक कॉन्स्टंट आउटसाइड द इंटिग्रेशन साइन. इथं कॉन्स्टंट कोणकोणते आहे? CD, coefficient of discharge, length of the notch or weir. Okay, and √2G, हे constant आहे. So we have to take outside the integration sign, and the remaining is 0 to H. Okay, 0 to H, H raised to half DH. Okay, so इंटिग्रेशन 0 टू H, H raised to half DH. ओके, याचं आपण स्क्वेअर काढलं म्हणजे अंडर रूट काढलं, त्याच्यामुळे H raised to half DH. नाउ वी हॅव टू पुट अपर लिमिट अँड लोअर लिमिट. सो CD, ओके, L √2G, then H raised to half plus 1 divided by half plus 1, 0 to H. Okay, if you do the integration then it will come H raised to half plus 1 divided by half plus 1, 0 to H. Then put upper limit minus lower limit. So CDL √2G, okay, H raised to 3 by 2 cross multiplication. Okay, so H raised to 3 by 2 divided by 3 by 2, 0 to H. Okay, then we have to take this here. This is in denominator. If you take multiplication on this side, so 2 by 3 2/3 CD L √2G, then 3 by 2. Put the limit also, capital H. So H raised. So this is discharge through a rectangular notch or weir. Okay, this is the total discharge through a rectangular notch or weir. Okay, rectangular notch or weir. 2/3 CD L root 2G H raised to 3 by 2. So remember this formula for a rectangular notch or weir. Okay. Now we have to solve one problem on a rectangular notch or weir. Okay. So the first problems on a rectangular notch or weir. Problems on rectangular notch or weir. So formula use. Okay. Formula use. कोणता फॉर्म्युला यूज करायचा आहे? Q इज इक्वल टू डिस्चार्ज थ्रू रेक्टेंगुलर नॉच और वियर 2/3 CD L रूट 2G H रेज टू 3 by 2. ओके, हा फॉर्म्युला आपल्याला यूज करायचा आहे रेक्टेंगुलर नॉच और वियर साठी. Where CD is coefficient of discharge and it is given in the problem itself, coefficient of discharge. Okay. Then L is the length of the notch or weir, length of notch or weir. What is this H? H is the head above crest level or sill level. Okay, crest level or sill level. तर हा फॉर्म्युला यूज करायचा आहे आपल्याला. Okay, so remember this formula for the rectangular notch and weir. Now the first problem, I request all the students please write down from your side also. Find the discharge of water. Find the discharge of water flowing over a rectangular notch, over a rectangular notch of 2 meter length, of 2 meter length, of 2 meter length, when the constant head, when the constant head over the notch is 300 mm. Take,
हॅलो
yes,
सर स्क्रीन ब्लर दिसते.
blur दिसतीये?
येस सर.
नाही सर.
हाँ,
क्लिअर आहे. क्लिअर आहे.
हो सर.
ब्लर आहे का कशी आहे? स्क्रीन चांगली दिसती ना मला तर इथं
ब्लर
चांगली.
दिसते सर.
ब्लर आहे.
क्लिअर आहे सर. क्लिअर.
क्लिअर आहे का?
यस सर.
ब्लर
नाही कसं
नाही
असतं,
सर, ब्लर आहे ब्लर.
नेटवर्क इश्यू असेल.
नेटवर्क इश्यू असतं तुमच्याकडून तर ते प्रॉब्लेम होतं बरं का. रिमेंबर दॅट इफ यू हॅव द नेटवर्क इश्यू, सम स्टुडंट आर द हॅव्हिंग सम नेटवर्क इश्यू. कारण माझ्या स्क्रीनवरती चांगलं दिसतं. एनीवन सांगा बरं मला, चांगलं दिसतं का कसं आहे?
क्लिअर आहे. चांगलं आहे.
क्लिअर आहे सर.
क्लिअर आहे.
Okay, thank you. So take CD is equal to 0.60. That is 0.60. That is the coefficient of. Now the solution first we have to write down given data. Okay. So what is given? first write down a rectangular notch is given. Okay, rectangular notch. Then length of the notch is given 2 meter. So L is 2 meter. Okay. Then L is 2 meter. Then what is given? Head, constant head over the notch is 300 mm. Okay. So head is 300 mm. That is 0.3 meter. Okay. Then CD is also given 0.60. Okay. Then we know that discharge through the rectangular notch. Discharge through rectangular notch. Two-third CD into L into root 2G h raised to 3/2. तो आम्हाला माहित आहे discharge through the rectangular notch or weir 2/3 CDL root 2G h raised to 3/2. So simply what we have to do, we have to substitute the value. Okay, 2/3 0.60. Okay, length is given 2 meter into root 2G 2 into 9.81 into h is 0.3 raised to 3/2. Okay, so calculate this Q. Therefore discharge is how much?
0.58 meter cube per second.
0.582 meter cube per 582 meter cube per second. Okay, so this is the discharge. So for your, if your final examination on MCQ type, then there will be a 2 marks problem on this formula for the rectangular notch. So remember this formula. असा 2 मार्कासाठी तुम्हाला क्वेश्चन येईल. फक्त तुम्हाला फॉर्म्युला माहिती पाहिजे. You can calculate the all the values is given itself in the problem. Same. The value of CD will given, length will given, and the head above the sea level is also given. So if you remember the formula for rectangular notch or weir 2/3 CDL root 2G h raised to 3/2, then you can compute the discharge. Okay, you can compute the discharge. So this is about the rectangular notch and weir. In the next lecture we will see the another derivation for the triangular notch or weir. Okay, so again I would like to highlight this one. Okay, so 2/3 CDL root 2G h raised to 3/2. So see here, this is the discharge over a rectangular notch or weir. We have the crest level, and if you see here, okay, now this is your edge. Okay, this is your edge, head above the sea level. Okay, and first we have to compute the discharge. अगोदर आपल्याला एका सिंगल स्ट्रीप इथून आपण काय केलं, हा पूर्ण स्ट्रीप आहे. हे बघा, सी लेवल वरून हा पूर्ण स्ट्रीप आहे.